Alright guys, welcome to RC Mojo. We're still working on the TXT1 this week. We got halfway through the renovations last time, so this time we're going to work on getting it rolling under its own power. First though, we're going to need to pop the gearbox out to replace the bushings. There's not a whole lot holding it in, just 2 screws per side. At some point I replaced the stock Tamiya screws with these self-tap Allen-headed ones. The sockets aren't formed all that well, so only the ball end on the Allen key seems to bite with any sort of consistency. With the 4 screws out, we can carefully remove the gearbox. It requires a fair bit of jiggling to get it to come past the chassis and suspension links, but it will come out without having to take apart the whole chassis. Before we can start to take the gearbox apart, we're going to need to remove the Traxxas drive shafts. It's just a case of undoing the screw pins and sliding them off. The universal joints are rather well worn, so we're going to need to replace them at some point. The plastic's so twisted the holes in the yokes are actually slots. The motor plate comes off next. There's 3 self-tappers and an M3 countersunk screw. The neat thing with this design is you can remove the plate without disturbing the motor positions and the mesh. Great for making it easy to service the gearbox. To take the gearbox apart, there's 2 pairs of screws and a single one at the bottom to remove. They're all M3 rather than self-tappers and have a plain nut in a hex-shaped hole on the other side. The top screws next to the spur gear didn't want to come out completely. I think the thread lock is getting in the way. They are free from the nuts though, so we should be good to split the gearbox halves. The shafts the gears run on are a fairly tight fit in the plastic, so it takes a bit of working back and forth to persuade them to slide out. And don't forget to remove the steel collar and gear from the top before the gearbox comes apart completely. You really don't want to lose that little collar. Well, it all looks nice and clean inside. We just have to give the top half a bit of a wipe to clean out the old grease so it's ready to refit. Right then, all the gears should slide out without putting up a fight. If they leave any bushings behind, they're going to need to come out too. Interestingly, we have another little ball bearing on the end of this shaft. I do wonder how much extra it would have cost Tamiya just to use bearings throughout. It's not like this was a cheap or low-end kit. The remaining bushings need to be swapped out for bearings. It's just a case of gently pushing them out and popping the new ones in. The output gear already has bearings, which makes sense as it's going to be seeing more side loads than the others. But it's coated in some very sticky gunge. It doesn't seem to have made it all the way inside the bearing, and after cleaning up with a paper towel around the shaft and the face of the bearing, it spins nice and freely. Okay, we can refit the 3 gears with the new bearings and give them a good spin to check for any graunchy spots. They should spin very easily and be nice and smooth. When you're happy with them, you can add some nice fresh grease. A nice blob on each of the gears worked around a bit will do the job, along with a little bit extra on the topmost gear so it will spread to the small gear behind the spur when we refit it. Pop the halves of the gearbox back together, making sure all the shafts are aligned before applying any pressure. Reinstall the 5 M3 screws, initially have them slightly loose, then tighten them all up a bit at a time until they're all nice and tight. Drop the spur gear in and give it a spin to double check that it's all turning nice and freely with no tight spots. Pop the steel collar over the end of the shaft and we can refit the motor plate. Now the pinion mesh is already set here, so I can just refit it without having to worry. But if you're changing the pinions or motors, you're going to have to reset the mesh. The easiest way is to remove the shaft the spur gear runs on from the gearbox and fit it to the motor plate and drop the spur and collar on. Set the mesh and then reassemble. We'll need to do it at some point as the Tamiya alloy pinions are looking a bit past it. The teeth are a bit sharper than I'd like. A nice steel pair would do the job nicely, but that can wait until we've got some replacement motors to fit at the same time. That just leaves 8 of the small bearings, and surprisingly they don't go in the driveline, rather they're for the suspension cantilevers. Now we could fit them, but I think the bushings will be doing a perfectly good job in that position, so we'll just leave them be. The gearbox can go back in now, and just like when we took it out, it's fairly easy to get it into position without having to take anything else off the chassis. Reinstall the 4 screws that hold it in. Now lining up the holes can be a bit tricky, but once you've got the first one in, the rest usually just fall into position. Next we've got the drive shafts. The Traxxas ones collapse enough that we can just fit them last. If you're still using the stock Tamiya ones, you might have to pop one of the suspension links off so you can move the axle away from the gearbox to get enough clearance to fit it in. So that's the drivetrain rebuilt and upgraded. The next step is to get the electronics installed. I'm going to be using a modified FlySky 9X, although actually I think it's a Turnigy, but it's the same radio, whichever it is. It's running the ER9X firmware, which lets us do some rather fancy things. It's the same transmitter we used with the Tiger tank. Before we can stick the receiver down, I'm going to peel off all that old Velcro. The radio tray is just a bit of styrene screwed to the damper mounts. The stock tray went all the way to the front of the chassis and had various bits sticking out to mount a throttle servo and mechanical speed control. To attach the radio, I'm just going to use a bit of servo tape, and for the ESC I've got a WP1040. Not sure how it's going to get on running two 27-turn motors, or if the Beck will like running the two 20-kilogram servos, but it's what I've got spare, so it'll do for a test run at the very least. The steering servo wiring needs to be carefully routed. I've always zip-tied the wires to the upper links with plenty of slack at the ends to take up any motion. It's important not to make them tight or they'll end up breaking off at the ends. The wires on the servos are a bit too short to reach the receiver, so for now I'm going to use a couple of servo extensions. They're going to work okay, but I'm going to be rewiring the servos with separate Becks in the not too distant. For now though, we'll just plug the front servo into channel 1, the rear into channel 2, and the ESC into channel 3. The transmitter's fully programmable in terms of what stick controls what channel, so it really doesn't matter where we plug them in, it just needs to be a bit logical. For the battery, I was hoping to use this 5Ah 60C pack, but this is an older Tamiya, so being a square LiPo, it doesn't fit. The pack sits too high for the strap to go on. If we have a look at the bottom of the tray, you can see the corner gussets that strengthen the box, but they won't let the square pack sit on the bottom. So out comes the round LiPo, which will fit perfectly. It's 40C, but it'll still be more than up to the task with plenty to spare. Here we are then, all plugged in, powered up with the transmitter on. I've done a bit of fancy programming on the transmitter to get the steering to do what I want. First, you've got your bog standard front wheel steering, and when in open spaces or driving fast, it's going to be ideal. However, the turning radius of the TXT1 is pretty bad, so with a flick of a switch we've got four-wheel steering. It's a big truck, so that'll get us out of any tight spots without having to do a 12-point turn. And of course, because why wouldn't you, with the switch at the bottom position we've got crab steering. Not entirely sure how useful it's going to be, but you never know. Another little thing I set up on the transmitter, the small switch next to the steering mode is set to limit the top speed. When driving FPV, I reckon the lower speed's going to be handy to avoid accidentally launching into the undergrowth. All that's left now to get the truck rolling is to refit the wheels. It's just a case of refitting the adapters and the nuts, so I'm just going to make that an instant edit. Very nice. They really don't make RC monster trucks quite like this anymore. You've got the HPI Wheelie King and the TXT2, but they're really just not quite the same. Right, so we could take it out like that, but it's an FPV truck, so we need to fit the FPV gear. There's still no proper mounts for them, so it's out with the Gorilla Pod again, and a bit of tape to make sure it doesn't fall off. The transmitter can get taped to the rear body mount bit, trying to get the antenna away from the camera as much as possible. We need a 3S battery for the transmitter, so that's just going to tape to the battery strap. And of course we need the camera. Well, that should do the trick. Let's see how it all works outside. Well, it all sounds pretty good. There's no ticks coming from the gear train. It's a little bit noisy, but that's just a large pitch on the gears, and you get that from a lot of Tamiya trucks. It's running in the limited throttle mode on the transmitter, which would seem to be plenty fast enough, especially when we're using FPV. I've changed the ground station setup a little bit since the last time you saw it. I've got a ThinkPad displaying the recording now, as my old MacBook's battery was far too gone to keep the machine going very long. The ThinkPad's running Linux and OBS for the display. OBS has the added advantage of being able to stretch the video so it's the correct aspect ratio. The only downside is the cheap USB composite capture dongle I got, as the ThinkPad doesn't have FireWire. It has a nasty habit of outputting a blue screen when the composite signal isn't great. I know there's some around that still output the distorted signal, it's just a case of finding one. The TXT1 as a platform seems to be working fairly well. There's no real vibration getting to the camera, it's all really rather smooth. For a solid axle truck, it's damping the motion nicely. While driving around, I found a black cat inside the fenced area around the old hall. It didn't seem all that bothered by the truck, so I drove around for a better view without the long grass. The four-wheel steering coming in ever so handy to turn around in a small space. The cat wasn't so happy with this angle though, and made a quick retreat. Well, that's about it then. The quick test was a success. I really need to find a different capture dongle though. Those blue flashes were really annoying. And that's about it then. The quick test was a success. I really need to find a different capture dongle though, as those blue flashes were really annoying. Next week's going to be gimbal week, I think, so we should be able to look around without having to manoeuvre the truck. The gimbal does look a bit flimsy though, so it'll be interesting to see how it handles the shake. So, as always, thanks for watching. Like if you liked, comment if you got something to say, and if you're not already, by all means subscribe. Bye guys!